Hello everyone, a very warm welcome to this video. In this video, we are going to go deep into what exactly is Hive. In the previous videos, we have seen that what exactly is Hive. It's nothing but a SQL layer on top of Hadoop. Now in this particular video, we are going to take a very deep look into how does Hive really work. So let's get going. So let's understand Hive in detail. Now, before we jump into Hive and let's say answer the question as to how does Hive really let us process the data, let's understand if this was an RDBMS. And let's say on my laptop we have a client for typing SQL queries. So what we would do is typically we would run a select command, something like select first name from employee where ID is equal to 75. Now when you run this command, we get our output from RDBMS and we are clear about it. But there is something interesting. Our hard disk does not understand what is a table. The only thing you can technically store on a hard disk is a file. So somewhere on our machine or on the server, we will actually have a file which is something like employee that will have the data in a very cryptic format. But RDBMS, they make you believe that there are tables, but in reality there are no tables. So the secret sauce is in the software. That means RDBMS software makes you believe that yes, there are tables that exist. But what they really have is on a high level something like a SQL to C. So when you run your query, the first thing that happens is it gets converted to a C program. What does C program really do is first it filters out the keywords. So what we realize is select is a keyword, first name is not a keyword. From is a keyword, employee is not a keyword. Where is a keyword, ID is not a keyword. Is equal to is, let's just say it's a keyword, 75 is an integer and semicolon is a keyword. So as of now, this SQL to C conversion cannot be done because RDBMS still has no clue about what is first name, what is employee and what is ID. That's where RDBMS, they have a layer of metadata where they would have information that looks like employee is nothing but a file, something like C program files. The first value or the first field is ID, that's field of 0. F name is field of 1. And the separator is tab. These are the details that the metastore will have or the metadata will have. Now, based on this, RDBMS is 100% capable of answering this question or your questions or queries. Now, how does Hive work? Hive is exactly same as this, where this becomes your Hadoop and here you have your file. The only difference is in Hive, the interpreter and the metadata both are on your laptop itself. Both are on your client itself. And instead of SQL to C, it is SQL to MapReduce. So the way RDBMS products, they make you believe there are tables. Hive also makes you believe that there are tables, but the major difference is Hive, the dictionary typically stays on your own client. Now, if the dictionary stays on your own client, then the biggest problem is how are you going to share your tables? If you have a team of 10 people, how are they going to share the tables? So the default behavior is, yes, the meta store gets created on local, but you are free to set up a shared meta store also. When you have a shared meta store, what really happens is entire team, they are connecting to the same meta store, and that way you will be able to share your tables also. So basically Hive is nothing but a sequel to MapReduce layer, which has intelligence of a mapping between a table and HDFS folder, and that actually can be stored on a shared location so that all the employees can share the table. This is precisely how Hive works. Now, in the next diagram, we are going to elaborate this further and we will start this entire sequence. So let's get going. Assuming that we have our Hadoop cluster, and as of now we have a single folder. A folder is called as let's say user training. So what we have as of now is let's say a Teradata database, Here we have our laptop. Laptop right now does not have anything. So the first command that runs on our laptop is yum install Hadoop client. This will install Hadoop client on our laptop. The next command we run is yum install scoop. So scoop gets installed. Now, if we have to get this data from Teradata to Hadoop, we will use scoop and we will get this data from Teradata to Hadoop. Let's say in Teradata we have a table called as employee, and now this employee would end up becoming a folder in HDFS, and within that we'll have the data. Within this folder we have the data file. Now once the data is in HDFS, the first option we have when it comes to analyzing this data is write a MapReduce code. Unfortunately, let's say we don't know how to write MapReduce code. So the next option that we have is we would like to, let's say, load this data into Hive and run this. So let's see how do we do that. The next command we run as administrator is yum install Hive. So what happens is on our laptop, three things happen. First, Hive gets installed. Next, a sequel to MapReduce layer is created on our laptop and a meta store gets created. a metastore gets created. As an administrator, there are two things we would do before we go further. First, we will create a directory called user hive warehouse. Now that's the default directory where Hive stores all its data. So we could visualize this as Hive's home. The directory is user hive warehouse. The next thing that we do is we set up a shared metastore. So instead of having metastore on our laptop, we will have a shared metastore, typically on a database like MySQL. So this is a shared metastore so that everyone in the organization could access this. So far we haven't created any data. All we've done is we've installed Hive and we've created a shared metastore. In the next command, what we do is we say create table employee with all the details. What really happens is in the user hive warehouse, a blank folder called employee is created. A blank folder employee is created. Then when we load data from path user training to employee, what really happens is this data file is actually moved. It is not copied, it is moved to the employee folder. And the metastore actually now has reference that a table employee is nothing but a location that is user hive warehouse employee, and it also has the structure information of the table. All that is in metastore. When you run a query on this table, the query actually goes to a SQL to MapReduce layer that actually talks to this metastore, and based on that it submits a MapReduce job to the cluster. So Hive's metastore is a dictionary that basically gives you a mapping between this table means this particular file. Now what we've done so far could also be called as a managed table, where data from employee moved to warehouse. There could be one more option where we don't want to move the data. So let's look at that example right now. So let's say in our Teradata we had one more employee called as users. We do the same process. We load this data into Hadoop, and here we have a folder called as users, and in users we have a file called as data. Now instead of moving, if we say create external table, this will actually not move the data but force the metastore to directly point users table to this particular location. So the data does not move, and the metastore would say users table is nothing but user training and users folder. So by default the data moves, but if you don't want to move the data, then your option is external table. That is how Hive really works. So Hive is a SQL on Hadoop layer. What it does is it takes your SQL queries and converts them to MapReduce, it seeks the help of a metastore which will store the mapping between a table and a file. So let's understand Hive with more details in the presentation. So let's look at Hive. Overview of Hive. Apache Hive is a high-level abstraction to MapReduce. Basically, you are free to write your SQL queries on top of Hadoop, and there is no need to learn Java MapReduce. Now, when you submit your Hive query, on Hadoop, it actually gets converted to MapReduce. So Hive interpreter will take care of that, and the job is run on Hadoop cluster. Why should one use Hive? Because Hive is more productive than writing MapReduce directly. 5 lines of Hive QL might be equivalent to 100 lines of MapReduce. Brings large scale analysis to a broader audience, and you don't need any software development experience. With Hive, you can use or leverage your existing knowledge of SQL. So you don't need a separate training on Hive, because if you are good at SQL, you are already a pro on Hive. Lot of business intelligence tools like Tableau can directly give you connectivity to Hive. You can get Hive just like a normal app from CDH. Let's see how does Hive load data. Now we've exactly seen that in the drawing. Hive queries operates on tables just like RDBMS. A table is a simple HDFS directory containing one or more files, and the default path is user Hive warehouse. Hive only supports formats for data storage and retrieval. How does Hive know the structure of location? It is because of the metastore. How Hive loads data and stores it? Exactly the way we've seen. When you run a query, Hive actually gets the location of the table and structure from a metastore, which would typically be, if it's shared, it would be typically MySQL. And based on that, it executes the MapReduce job. So how does Hive compare with traditional databases? Now, our cluster is not a database server. We've already seen that Hive is just a layer so that you don't have to learn MapReduce, but otherwise it's not a competitor or anywhere close to RDBMS. Client-server database management systems have many strengths: extremely fast response time, support for transactions, allows modification of existing records, can serve thousands of simultaneous clients. And Hive does not turn your Hadoop cluster into RDBMS. These are certain differences. When it comes to querying language, in RDBMS it is SQL, in Hive it is HiveQL. Can you update individual records in RDBMS? Absolutely, but you cannot do that in Hive. Can I delete individual records in Hive? Yes. In RDBMS, yes. In Hive, no. Can I have transactions in RDBMS? Yes. You cannot have transactions in Hive. Is there an index support? Extensive in RDBMS, very limited in Hive. So these are certain differences between Hive and RDBMS. Use cases: log file analysis would be one of the most important use case of Hive. You can also do user sentiment analysis. So the use case between Hive and Pig mostly remains same. Now let's understand how can you use Hive. You can use Hive from the command line. So this is a Hive prompt. Once you get there, it's all about running those basic SQL queries. That you already know of. So there is no additional effort or learning curve involved if you are going to learn Hive. You can also execute a file. So you can create a set of queries and save it as a HQL file, and you can run directly the HQL file. You can set properties in Hive. And just like pig shell, that is grunt, from Hive also you can write shell commands, and you can also manipulate the HDFS file system. You can also manipulate the HDFS file system. Hadoop has a user interface tool called Hadoop User Experience, and you can also access HDFS or Hive directly from Hadoop User Experience. And from the browser, you can create tables, databases, run queries, browse tables. Everything that is possible from command line could be done from the Hive editor in You can run all your queries, see the results and logs, you can play with. So this was all about Hive. In the previous 3 videos, because all 3 are kind of SQL to Hadoop, so in the first video, we introduced what is Hive and Pig. In the second video, we spoke about what is Pig. In the third video, we are speaking about, or in this video, we are speaking about Hive. There is one more framework that involves SQL on Hadoop, that is Impala. And in the next video, we are going to talk about Impala. Thanks for watching this video.